Here's the Mark 8 in a test bed. Been using it to check the boards, circuit boards for the memory, various memory boards. Right now it's running through the memory test program for the 16K board. Actually 32K with two 16K chunks that I've been working on, and the lights are just giving us an indication of not only that it's running but where it is. Here's the low 8 bits of the 14-bit address, and here are the upper 6 bits. The machine can address 16K, well, so 14 bits is what it takes in order to address all the memory. And 15 and 16 over here are the high order bits of the high register, are really the clock timing codes from the CPU. You'll notice I've also got the little boards I was telling you about to display the output ports, and I use those one on each port, the 7 ports. You might recall this is the port 0. Here's port 1, 2, 3, 4, 5, 6, and 7. And when the program starts, it initiates the output ports to a 1, a 2, up here is a 3, here's a 4, you can see the binary code, 5, 6, and 7, just to verify that the ports are working, since I made that board a while back and I've been testing that also. The original 8008 or Mark 8 only had 4 ports on its output card, and you needed 2 of those to get all 7. So when I redid the board, I just put all 7 ports on one board. If the memory program finds an error, then it'll stop, and it'll have the low address here, the high address here where the error occurred, and up here will be the data that was in memory and the data it was comparing to try to figure out what the difference is, which helps in debugging the program. Otherwise, as long as the memory test's okay, it just sits in a loop, and that's what it's doing. I had a problem with some of the cards. I built up about 3 or 4 of these, and there was kind of a funny problem. It was like magic. I'd wave my hand in front of the machine, and bam, it'd find an error and it would stop. So I got out the application notes for the multivibrator, monostable multivibrator, this 74123. I'll show you the board here in a second. And I used that circuit, which was provided by Brian Blackburn. Then I looked at it in more detail, looked at all the write-ups on the engineering specs, and found that the capacitors are fairly critical. I use disc capacitors, which are all right, and I've got a LCR bridge, so I was able to pick out the one that was close to the right value. Brian had specified a 30 picofarad capacitor for the delay, so I calculated the time delay that we'd get with the 74123 and a 10K resistor and the RC time constant. I came up with 0.2 nanoseconds, which should be okay. We've got like that should be plenty of time to wait until the lines stabilize before we let the right pulse go through. The address lines in the original version of the board were not fully in position when the right pulse came to the IC, so you never knew what it was going to write. It was just sort of random. With that delay in there now, it seems to work just fine. Well, I had a 33 picofarad cap in there, so I changed that out to a 30 and measured it on the LCR bridge, and that seems to work fine. I also found that the external capacitor pin on both sides of the 74123, it has 2 monostable multivibrators in it. One feeds the other one. The first one gives you the delay, and the second one gives you the length of the pulse that you want the final pulse, right pulse, to be. And that's okay. That's working fine. So I replaced that capacitor, and it seems to be working just fine. but that the external capacitor should also be connected to the external ground. According to the application notes, it's connected to the internal ground inside the IC, but we have to have it also grounded to the external ground plane, which gives us more stability according to the specifications. Also, the external capacitor and the resistor that form that RC to give us our time constant have got to be as close as they can be to the chip, actually. And if you get over 3 centimeters, which is a long ways on a PC board, you get over 3 centimeters and it'll start throwing things off kilter. So I did, on the new version that I just sent into JLPCB in China, I put relocated the entire chip closer, 74123 closer to the memory chip, and I moved the components in closer to the 74123. I made the traces a little bit wider in order to cut down on inductance. I didn't want a lot of inductance, stray inductance or capacitance getting in there to mess it up. And I'd made some of those changes manually. I just modified the circuit board. I grounded the external capacitor pins, and I put the 30 picofarad cap in there instead of the 33, which I'd measured now on the LCR bridge. And as you can see, it's running fine. So I think that took care of that problem. And I'll show you on the board kind of how what I went through there. These changes have been made on the new board, and I hope we can get through Hong Kong with all that trouble they've got going on there. They'll be mailed out of Hong Kong, and the situation over there doesn't look really all that cool right now. Well, here's the board, the one we're working with right now. Down here is the 74123 and its associated circuitry. The two parts of the 74123 are the first one with the 30 picofarad capacitor here is to generate the delay, and the second one then generates the right pulse and controls the width. Those components are over here. So I moved those in even closer to the IC. I made the traces broader, and I moved the whole works up here so it's closer to the 61256 memory chip. That's about the best I can do, and I think since I made the changes down here, it seems to be working fine. So that's just an insurance policy to bring it up here a little closer, and I think that'll straighten it out. I've also made the select card changes that we talked about, so that it's going to shut off both of the bus 74 LS 244s. That's the bus line driver, line receiver, and when this board is not selected, it'll shut them off completely. They won't ride the bus like they were before on this input side, and I think that'll clear up our problem with interaction between this and the fixed memory portion of a 1K or a 4K board also running in concert with this one. That should pretty well cover the changes that we're gonna get on our new board. It's 50% done. I just checked the status of it at JLPCB over in China. Once it's done, they'll ship it over by DHS. Takes about 2 days. Goes from Hong Kong to Cincinnati, and from Cincinnati to Omaha, and from Omaha DHS center right to the door, my front door. So that gives you an indication of where we're at on the memory. 32K memory board cut into two 16K chunks. Now I'll put the circuit up for you to take a look at on the computer. Okay, here's the schematic of the delay portion of the 74 LS 123, and you can see I made a couple of changes here from the original, where the capacitor external capacitor used to connect directly into pin 14, and internally pin 14 goes to ground. Recommendation on the application note was to take pin 14 to ground, place C1 as close as you could to it, take that also to ground, so you get the external ground plane involved for a little better ground, lower impedance ground connection between the capacitor and the resistor in the RC network. And this is the first half of 74-123, which generates the delay, and the second, it feeds into the second half, which generates the pulse itself, the delayed pulse, out of this pin, out of pin 12, the not Q. It'll generate the delayed pulse, and this, here I've done the same thing with the external capacitor. I've run that to ground on the outside, put the capacitor part of the RC network very close to that pin, also ran that to ground. We get ensure a low impedance path that way. That again is according to the application notes. And I moved that whole works. You can't see it on the schematic. I'll show you the actual PC board in a second. I moved that whole works as close as I could get it to the actual memory chip, UT61-256. That'll keep those paths as short as possible, reduce inductance, travel time, which isn't that big a deal at these low high frequencies. So anyway, there you have it. And we're going to make sure now that this is 30 picofarad and not a little above or a little below. I measured those in the LCR bridge before I used them, just to make sure. And the same with this. I believe we have a 10 picofarad right up here. We measured that also just to double check, just to be sure. So all the timing constants are solid from our calculations. All right, let's take a look at the schematic here at the PC board. Sorry. Here's the actual placement on the PC board that we just sent off to JLPCB for manufacture. The green lines are on the bottom of the board, and the red lines are on the top of the board. But here's our 74-123, and you can see that our two external capacitors for the timing constants are about as close as you can get them to the chip now. And we've also taken our output from the external capacitor pin on the chip. This red line coming through the middle, the thick one, red one is the ground plane. So we've connected that directly to ground. Goes through the pad into the capacitor, connects the capacitor also to ground. So that's a very low impedance path there between that pin and ground. That's what we want. Same way on external capacitor number 2, which is for the delayed pulse output and to calculate the duration of that pulse. That's what that capacitor is for. That we did the same thing. We have that capacitor as close as we can get it to the ground plane right here. Goes right into the pin and then into the ground plane, this red ground plane coming across here. And the output, we've moved that shoved that whole thing from where it was on the other board. If you'll recall, way down the corner, we brought it up, rerouted everything, and gotten it as close to the 61-256. It got a little glare on that, but there, I think you can see that's the 61-256 memory chip. And over here we have our selection for either single board or a multi-board configuration. The multiple board select. So that's where we're at. Those boards will be here in a few days. We'll stuff one, plug it in and see how she comes out. I don't anticipate any problems, but you never know. Okay, that should wrap up this part of it. Thanks for stopping by. If you have any comments, let me know. If I'm forgetting anything, which wouldn't be unusual. Ciao for now, gang.